Hello everyone. In this video we are going to be starting officially day 1 of proofs. Now in the first part of the video we're going to be talking about the different types of logical reasonings and the different kinds of laws and rules that go along with those types of reasonings. In the second part we'll get into some examples and make sure that you actually know how to set up and then complete these proofs. But first let's begin with the different types of reasoning. So there are two kinds of reasoning. There is inductive reasoning and there is deductive reasoning. Now, inductive reasoning is very similar to an educated guess. Right? It is when you make a conclusion based off of examples or observations. So in this example, you have the classic lucky socks from any athlete. So Katie wears favorite pair of socks to the softball game, she makes a hit. Next game, she's wearing her favorite socks, so she thinks that she'll get a hit because of this pattern that has been established. Inductive reasoning is used in a lot of things. We use it a ton in our life, but it is always an educated guess because it's only based off of patterns. All right, there really is no hard and fast rule or law behind the lucky pair of socks. All right, it's just a pattern that you have observed. The second reasoning is the opposite of that. So inductive reasoning is an educated guess. Deductive reasoning is a conclusion built off of facts, rules, definitions, all that stuff. So an example of this would be, or someone who uses this, is Sherlock Holmes. All right, if you've ever watched one of these detective movies, Sherlock always notices a fact or a reason. He knows that there was a tunnel built because there's fresh dirt. There's fresh dirt over there. That means that someone must have been digging. All right, he uses facts and rules of life to logically conclude who the killer was or who the mystery person is. All right, another example of this is this bottom one. So if you're late on a car payment, you know that if you're late on a car payment, there's going to be a fine. So if you're late on a car payment and you get a fine, well, you know why. There's this rule. Okay? Inductive reasoning is about patterns. You're guessing. Deductive reasoning is using rules, laws, facts, those kinds of things. That's why deductive reasoning is the only one considered to be logically true. Because you start with a fact, and that means your conclusion should be a fact. All right. Deductive reasoning is the one we'll be using the most when it comes to proofs. The way this works is for every proof, you will be given a statement. This statement you know 100% is true. Then, based on that statement, you will use different facts, different postulates, and different reasonings to make another equally valid conclusion. And that's deductive reasoning. Now, deductive reasoning has two laws. Okay, ignore the group investigation bit. All right, the two laws of deductive reasoning are the law of detachment and the law of syllogism. Now, the law of detachment states that if P, then Q is true, and P is true, then Q is true. Now, that may seem a bit confusing, but once you have an example, it's a bit easier to see. Given the example I have up top, so if you get a license, then you can drive. Here is your if P, then Q. All right, P is if you get a license, and then your Q is then you can drive. Now, law of attachment, you're told this situation, you're told the scenario, and then you get an extra piece of information. You are told that the hypothesis is true. So in this scenario, the extra piece of information would be you get a license. The question will then ask you, what conclusion can you make of this? Well, if P is true, if you get a license, then based off of the original scenario, the hypothesis or the conclusion must be true as well. So then you can drive. Your conclusion is, then you can drive. And this is the law of detachment. The law of detachment is that you're given a scenario, you're told the hypothesis is true, and therefore you can conclude the conclusion is true. All right? It's a bit of a circular. Basically, you're saying something, and then you're confirming the whole thing is true. Law of syllogism is a bit different. Whereas law of detachment is kind of a circle where you're given a scenario and you stay in that scenario. Law of syllogism is when you string information together and then you see that the first piece of information connects to the last piece of information. So let's look at this scenario. Same starting sentence. If you get a license, then you can drive. Then you're given another piece of information. If you can drive, then you can go on a road trip. Your conclusion would be, if you were to ask what conclusion can you make, the conclusion would be, if you get a license, then you can go on a road trip. Because of the law of syllogism, you can easily see that these two sentences, even though they're separate sentences, they are connected because they both share this phrase, you can drive. Okay? So if P is true, if the original P is true, you get a license, then you can drive. If you can drive, all right, then you can go on a road trip. Because the cue, each sentence has the same cue, logically, P then also leads to R, which is what this whole thing is saying. As we go on in the semester and the year, we will be using the law of syllogism for the most part in all of our proofs. Okay, 9 times out of 10, we will use the law of syllogism because this is the best way you can prove something is logically true, by slowly, step by step, connecting all the different pieces of information. This is why, as we get into proofs, it is so important to write down and explain every single step. Because what you're really doing is showing in detail how all this information connects. All right? The biggest trick on how to tell detachment apart from syllogism is detachment stays contained in itself. You start with P and Q, you're told P is true, then you know for a fact that Q is true. Okay, that's detachment. Syllogism, like I said earlier, connects the information. You start with P and Q, you're told about Q and R, and then you can connect P and R. Okay? You're given new information, and then you can connect your first piece of information with your last. Now then, the pieces of information that you will be connecting, those are called postulates and theorems. Now, a postulate is a statement that describes basically the fundamentals, the basics of geometry. Postulates are accepted as truth. If you're told something is a postulate, you don't have to explain it. You don't have to prove it's true. It just is. Okay? Pause and answer this question in the Edpuzzle. Now, the two postulates we've come across, I can't write down there, so I'm going to write up here, are the segment addition postulate and the angle addition postulate. Both of these are fundamental concepts of math. If you add two things together, you get a bigger thing. There really is no more explanation required. Those are postulates. Most of your definitions also fall into postulates, but definitions are separate. They're by themselves. The second thing on this page, though, is theorems. A theorem is a statement or conjecture that has to be proven. Okay, you can't just say, oh, this is true because of this theorem. You have to prove the theorem is true first. However, once you prove that theorem true, then you can use it all the time. You don't need to continually reprove it. An example of a theorem you've probably used or have heard of is Pythagorean theorem. A squared plus b squared equals c squared. And this is how you find the third side of a right triangle. Somebody had to prove this. Pythagorean was actually the one that proved this. He proved that it was true for everybody every single time. But before he could say that this is true every single time, he had to go through and logically draw out every single step so that everybody around him knew that this was a fact. This is what you have to do with all theorems before you can use them. You have to draw them out, draw the logic out, and explain step by step by step why you know it's true. And as of right now, guys, welcome to geometry, because geometry fundamentally is proving and explaining why the things you do work. All right, that's the whole point in doing all of these proofs. Now, this down here is a simpler explanation of what I said. Basically, the important parts is that it's a logical argument in which each statement you make is supported by why it's true. It's supported by the postulate or the definition or the explanation on why you can do that. You need to prove things in order to convert a statement or a conjecture into a theorem. Unless you can prove it, then it's just an idea. You can't make it a fact. Okay? When you're writing a proof, it's very important to be clear. Okay, so that means there's a couple of steps and a couple of things I'm going to be nitpicky about, because you have to have them in order for me to see that you have made the logical train of thought. First and foremost, you need to state the given information. Like I said earlier, in every proof, you will be given something that you can accept as true. Okay, you're told that these two things equal each other. Okay, that's the scenario you start off with. So in every proof, you need to restate your given. Then you're going to walk through a deductive argument using either the detachment or syllogism. We will most likely be using syllogism. Like I said, 9 out of 10 times. Every step has to be justified. Okay, so if you add 4 plus 4 and you get 8, this step needs to be proven. How did you get 8? Every step needs to be proven, needs to be justified. Otherwise, I could argue you just made that up. Right? And you always end with what you're trying to prove. What this means is you're never going to use what you're trying to prove in the actual proof. It's kind of like you can't use the word in the definition. If I asked you to explain, what does bubble gum taste like? You can't go, Miss Stockton, it tastes like bubble gum. That does neither of us any good. You have to describe and draw out each individual piece, and then your conclusion is, this is what bubble gum tastes like. Now, in order to write a proof, we're going to need a few more statements and postulates than the ones we already have. Okay? If you need to pause and write these down, that would be a very, very, very good idea. So pause and write these things down. I'm assuming you already paused and written them down, so I'm just going to keep talking and explaining. So these are properties of algebra. You learned this in algebra, and these are the things that you're going to use for algebraic proofs. Most of these are pretty self-explanatory, so I'm not going to go into them. I am going to go into these two right here. Transitive and substitution. Now, the transitive property is very similar to the law of syllogism. In fact, you could say that syllogism is the letters and words version of the transitive property. What the transitive property means is that you can connect information. So if A equals B and B equals C, then you can conclude that A is equal to C. We'll be using transitive a lot. Substitution property is very similar to the law of attachment. It is kind of contained in itself. All right, if A equals B, then every single place that you see A, you can plug B in, and vice versa. These two get confused a lot when we're doing proofs, so I just want you to remember that transitive property is when you string information together. All right, you're connecting a whole bunch of pieces together. Whereas substitution property is you have something equals a value, x equals 4, and then you're plugging 4 into all the different places where you see x. If you have any questions about these, please feel free to ask, but for the most part, these are rather self-explanatory properties that you just need to write down on your flashcards and have memorized, because we will be using them. Okay, let's get started. What I'm going to do now is I'm going to walk you through two types of algebraic proofs, and then I'm going to walk you through at least one geometric proof. So the purpose of the algebraic proofs, they look simple, they are simple, but the purpose of these is to get you in the habit of doing proofs and so you can see the different setups and structures. So let's get started. Now first, if you are looking at your notes from earlier, you know the first thing we have to do is write our given statement. That is the hypothesis. Now, sometimes it'll be given to you as in like actually labeled. This is your given piece of information. But whenever you have a sentence like this, your given piece of information is your hypothesis, which means that this is my given and this is my conclusion. Okay, so x equals 2 is what I'm trying to prove. Now remember, as I write this down, you cannot use the word in the definition, okay? A common mistake I see on these is people plug into and then they do something, okay? You are not going to write x is equal to 2 until the very last step. Do not plug it in. Okay, so you're going to write this first statement, and then off to the side, your reason is that it is given. You will always have given for your first reason. Then you're going to solve. Solve one step at a time for algebraic proofs. So my second step, I'm going to distribute, and I have 3x minus 15 over 3 is equal to 1. My reason for this is the distribution property. That is most likely not how you spell that word, but that's okay. Now my next step, I've got to simplify this fraction. So I have 3x minus 5 is equal to 1. Now I got 5 because 15 divided by 3 is 5. So for my reason over here, I'm going to put division property. Okay. Then I'm going to keep solving. So I'm going to add 5 to both sides. 3x is equal to 6 because I added 5 to both sides. This is addition. Okay. And last but not least, I need to divide 3 from both sides to get x all by itself. And this is my division step. Okay. Now I'm all done. I can't do anything more with the math. And so the last thing I'm going to do is check and make sure that my last sentence matches my conclusion, which it does. And that means we did our job right. Whenever you are done with a proof, the way you show me that you're done with a proof is you have a sign-off symbol. There are 3 kinds of sign-off symbols. You can either write QED, you can either write a square colored in, or 3 dots in the shape of a triangle. Okay. These 3 symbols, pick your favorite. My personal favorite is the box, but pick your favorite. You have to have these at the end of your proofs every single time. Every single time. It's like the period at the end of a sentence. If you don't have it, then I think you're not done. Okay? So always make sure you sign off on every single proof. Now let's go to the next one. On this one, you're going to solve it for yourself. So I'm going to get you started. I'm going to remind you what the very first step is, and then the video is going to pause and you're going to finish it off. Remember, your last sentence should be your conclusion. Do not plug y into this equation, otherwise you won't get the right answer. But so to start off, this one's nice. It tells you what is given. So your first step is you're going to write that down. All right, you're actually given 2 things here. You're given the equation, and then you're also given that x is equal to 2. All right, and this is your given. This is what you're told from the start. Now, a good trick with proofs, if you don't know how to start or how to continue, is to look at what you're trying to prove. In this case, we are trying to prove that y is equal to 23. When you look at your equation, or when I look at the equation, I see that we have a y and we have an x. In order to solve for y, I need to get rid of that x. I'm given what x is equal to. So, knowing all of that, knowing I want to know what y equals, the best next step would be to plug in x. Okay, I'm going to pause the video here, give me the reason for number 2, and then finish it out. And here is your answer. The second step is substitution, because you're told that x is equal to 2, and then you plugged it in, so you substituted 2 in for x, and the rest of it was basic algebra. Make sure that you included your sign-off symbol. Okay, it could be the box, it could be QED, it could be the 3 dots, doesn't matter to me. Okay, just make sure you have it. I will say on the 3 dots, if you're picking that one, please make sure they're actual dots in the form of a triangle. If you just have 3 random specks, I won't believe you. Okay, make sure that you actually have physical dots. All right. Now, last but not least, the geometric side of all this. Okay, proving algebra is fun and all, but let's get to the big part. These are your geometry postulates, proofs. They're very similar to the ones you've already seen. But again, in geometry, you have to prove that the things you're doing are correct. So even though we've already said these things with numbers, we have to again re-say these things work with symbols, which is what this chart is. Pause the video and write that down. I'm assuming you've done that by now. I'm going to move on. And let's do a geometric proof. T-table is required. Now, geometric proofs, exact same setup, only now you're using the postulates we've already learned. So the first step is still to write out the given. And here is where knowing all of your different symbols becomes important. All right. And in this one, we are actually told a lot of information. Oops. Oh well. All right, so all of this is our given statement. This is what we're told. Now, whenever you have a geometric proof, after you write the given, it's always a good idea to look at your picture and annotate as much as possible. We are a very visual culture, so the more you can draw, the more you can write, the better your life is. So we are told in our given that FGJ is congruent to the angle JGK. Sheesh, say that 10 times fast. So this angle is congruent to JGK, this angle right here. You are then told that angle JGK is congruent to angle KGH. Okay, so that means this angle right here is congruent to this angle right here. Now, if this angle, these are the same two angles, if angle JGK is congruent to both FGJ and KGH, then what we can do, because of the transitive property, we can put those two things together. So we can say that angle FGJ is congruent to angle KGH. And again, this is because of the transitive property. All right, we are stringing pieces of information together. Then, in our next bit of given, we're told the values of these two angles. So we're told that FGJ is equal to 6x plus 7, and that KGH is equal to 8x minus 5. What we can do now in our next step is we can take those values and plug them in to this new equation that we've written. This would give us 6x plus 7 is congruent to 8x minus 5, and this is substitution. All right. So first, we could set the two angles congruent to each other because of the transitive property. Then, since we were already given those two angles' values, we can substitute the values into this equation that we wrote. Now, last but not least, we need to change out our congruent sign for an equal sign. Don't forget, congruent symbols are for shapes, equal signs are for letters and numbers. So I'm going to write 6x plus 7 is equal to 8x minus 5. And this reason is actually a definition that we learned in chapter 1, and it is the definition of congruent. This is why I said if you haven't started investing in flashcards, you are behind in the times, because all those definitions, all those things are coming back. Now to finish this off, we're basically doing algebra. So I'm going to subtract 6 to the other side. So 7 is equal to 2x minus 5 because of subtraction. Okay, add 5 to the other side because of addition. And then finally divide. Before we're done, the last thing we got to do is double check and make sure that our conclusion matches the one we were supposed to get. So 6 equals x, 6 equals x, we are done, we can sign off, and that's it. And that is the first official day of proofs. When you're doing these things, it's good that you're following along, it's good that you're writing along with me, but always make sure that after you do a proof, go through and reread it, read it out loud. Okay? Like most math, proofs are very obvious when someone else is doing it. So whenever someone else does a proof, you need to go back and make sure you understand every single piece. Heck, even restart a few proofs that we do in class. And this will help you get a flow for the logic. Once you start seeing the pattern and the logic flow, your math life will get a lot easier. That is it, guys. I'll see you in class.